So now we start lecture 2. It's about the motion in 3 dimension, but now we used it in 2 dimension. And we know before in last lecture we know how the object move in 3 dimension, how we can describe it in position, how we can find it velocity as instantaneous or average or acceleration. Today in this lecture we discussed about the motion in 2 dimension, and the example of the motion in 2 dimension, it is a projectile motion. What is the mean of the projectile motion? It is the motion of the object under the influence of the gravitation force only. So that means there is one condition, and very important condition, بأنه حركة المقذوف هي حركة للجسيم أو الحركة للأجسام تحت تأثير فقط عامل واحد، وهو الجاذبية، قوة الجاذبية. The other things, it is neglected. Wind, air resistance, so all of this, it will be neglected. So now we start to describe this thing. If you have any object and this object moves in, or you firing it or launched it up, so it moving up till points, from this point it fell down to reach the ground. أي مقذوف يقذف إلى الأعلى فسوف يقذف بسرعة، هذه السرعة تسمى بالسرعة الابتدائية في initial، وراح تكون له زاوية theta initial. So any object you firing it up or launched it up, any projectile, so it's necessary to move with initial velocity and also with initial angle. First, we described about the first point here. It's firing from y equal to 0. What's the mean of equal to y equal to 0? So that means it's starting from here. So if I firing any object or launched any object, it moves with initial velocity and initial angle, that is the firing angle. Then it moves till point, for example, point 4. In point 4, it changed its direction till it reached to the ground. So if I pointing to describe the points for this object, so from start it is point 1, then point 2, point 3, 4, 5, 6, 7, and I try to explain what is in these points, what is the velocity in x and y, what it change in these points. So I start from point 1, it is the firing point, and from here, from the start, the projectile motion, same as free fail, but, and put here underline 6, 7, 8, 10 lines, but the different, it is the angle of firing. The angle of firing نفس السلوك اللي يسلك السقوط الحر أو المقذوف اللي يقذف إلى الأعلى أو إلى الأسفل، نفس الحاجة مع projectile motion، مع المقذوفات، ولكن الاختلاف هنا في الزاوية. زاوية المقذوف أصبح هنا لازم يتم الاهتمام بهذه الزاوية ووضع حسبان لهذه الزاوية. فالاختلاف سوف يكون ما بين الفري فيل والبروجكتايل هو the firing angle. So first, when we teach the student in high classes, we mention to them it's the same, but there is one thing here. Their grandfather or grandmother, it's theta I, so she did after it moved. So now the two dimensions, the two coordinates each one need to take what is the position of I with it, theta I, and in Y, what is the effect of this angle with Y. يعني لما كنا ندرس الطلاب كنا نقول بأنه المقذوفات نفس السقوط الحر، ولكن الاختلاف هنا في زاوية المقذوف. فنفترض للطلاب بأنه جاتهم عمتهم أو جدتهم اللي هي زاوية المقذوف، بعدما انطلقت ماتت، فأصبح كل واحد يطالب بإرثه من هذه الزاوية، إيش اللي أثرت عليه هذه الزاوية، إيش اللي أعطاته، إيش اللي راح يأخذ منها. فالإكس راح يأخذ نصيب والواي راح يأخذ نصيب، وهذا هو نصيب الإكس والواي in point 1. So first equation at point 1, that is here X, here Y. So V I in X, or Vx, or X, it's equal to Vi cosine theta. So the V initial is same. V initial is equal to, in X, Vi cosine theta. Okay? Vi cosine theta. Vi cosine theta. Now Y. So Y here, Y is equal to Vi sine theta. So that is the first equation, and very important, please be careful about this equation. Second, in second point, so the velocity always tangent to the path. The velocity always tangent to the path. Velocity is tangent to the path, so X is up, Y is up and X in this direction. Point 3, same, V in tangent to the path till point 4. In this point 4, the object finished its initial velocity. It will not have any velocity. So in that point, Vy is equal to 0. Then the object change its direction from up to down, because the gravitational force worked now to take the object down. First, the gravitation try to reduce the speed, the velocity of the object till this point. In this point, now the gravitation works 100%. It pull the object down, so it makes strong to take the object to the ground, to its direction. In point 5, so Y is down, V is a tangent, and X same, so there is no change in X, so the changing in Y. Till point 7, point 7 is the reference point, that is the object reach to the ground. So now I described these things in X and in Y. when we want to describe the motion in each direction and which direction the works is more in it, so we can make one experiment by using oscilloscope, or we can make a dark lamp and launch it an object and check what is the effect in X and what is the effect in Y. So if I want to describe the effect in Y, so just I lighting, or I take my lights to direction of Y to see what is in Y. فإذا أردنا أن نحصر أو نرى حركة المقذوف في أي جانب، أو كيف تكون حركته على الواي وعلى الإكس، فنفترض يما باستخدام الستلسكوب الوماض، بحيث أنك تقذف الجسم وتصوره تدريجيا وتشوف إيش حركته، أو أنه تستخدم مختبر. هذا المختبر يكون معتم تماما ويتم تسليط إضاءات إلى الجانب اللي أنت تريده. أريد أقيسه على الواي، إذا نسلط الإضاءات على الواي. فالآن أريد أقيس على الواي. I want to check in Y. So in Y, what is the object do? So in first point and check it with my points. So in first point, it's here. Then the object moves up in point 2. Then still moves up in point 3. Still moves up till point 4 is the last point of the object. In this point, the velocity is equal to 0 in Y, and the object in this point, it reached the maximum height, and we discussed how to find the maximum height, delta Y, that is the maximum height from here to here. Then the object change its direction from up to down, then that is the 5th point, the 6th point, then it reach the ground. So we see there is 2 type of motion, up and down. And the effects under the influence of the gravitation. So the gravitation from launching, it keeps the object to move till the points. It reduced it till the points. This point is a maximum height. From the maximum height, the gravitation works with more force and take the object to fall down freely with under the gravitation only. Then if I want to check the points in what is in Y, so just I zooming my light in this from this way. So I put my lights here and check my points for the object. What does the object do? So in point 1, the object is here. Point 2, the object is here. Point 3, point 4, point 5, point 6, point 7. So in horizontal, in x-axis, so it is no effect, no force. Just the object moves with the changing its position with the time. It's the same as the object move in one direction, for example in x-axis only, but the object change its position under the time. So now the important things in this diagram, that is the firing from 0. So that means there is something. So if you check here the time from launching to reach the maximum, I assume it T1. The time from maximum to reaching the ground, T2. So if you check this shape, this part identical or symmetric to this part. So the time of the object to flight to the maximum point, it is the same from the maximum point to reach the ground. So what is the total time? T total, so it's equal to 2t. What's the mean of 2t? So that means t1 plus t2. What is the maximum point? It is the point that is the object reach a maximum height when its velocity is equal to 0 in y. Here, what is the point between 1 and 7? It is the maximum point between, or a maximum distance between point 1 and point 7 in x direction. So that means the maximum range. So delta x. So that is important 3 points. How we can find it as an equation. So now we go through the equations, kinematic equations. Then after that we can take the equation for the maximum height, the range, and the time of flight to reach the ground, or the time of flight to reach the maximum height, or from the maximum height to the ground. We can take it. So now I want to apply the 3 important equations, 3 kinematic equation that I used in free falling, in x and y, and in component factor position. So first of all, I know there is no effect in x. So that means here I want you to be careful. There is 5 important variables. Please be careful about it. In x, in y, in r, as in or in 3 dimension, in 3D. So the 5 important variable, it's v initial in x, y, 3 dimension. Then v final in x, y, and space. Acceleration in x, y, space. Delta x or delta y or delta r, that is in x only, that is in y only, that is in space. And the time, it's changing with all of these 3 components, in x-axis, in y-axis, and also in space. It's common, you cannot change the time. The time, it's moving when the object when the object moves, so the time it will be goes on. You cannot change the time is fixed. So the 5 important variables v initial. هناك 5 متغيرات أساسية يجب على الطالب أن يركز عليها في حساب أي معادلات للحركة الخطية، سواء كانت في بعد واحد أو في 3 أبعاد أو في بعدين. أولا السرعة الابتدائية V initial، في بعض المراجع يسموها V naught. V final السرعة النهائية. In some other references V only or V2 or here V1, so it depends on the references, but here we used it V final as F, small f. Acceleration, the distance or displacement in each component, and the time. So these 5 important variables you must know about it. So now we put these 5 variables in each component that we need to find the equation for it. So now at x-axis we know in x-axis there is no any effect of the gravitation force, so that means the acceleration of the gravitation is equal to 0. So put here 0, 0, 0. So V final x is equal to V initial x. So from equation 1 we know V initial x is equal to V initial cosine theta. Just replace here V initial with cosine theta. This part, the acceleration is equal to 0. So this part is 0. So the equation is V initial x is equal to V initial cosine theta in x. It is the first equation. From second, the square. This part is equal to 0. So V final is equal to V initial. Same. So there is no change. V initial is equal to V final because it changing with the time. The velocity is same, but it's changing with the time, the position of the object. Delta x from this equation, here put x, delta x equal to V Ix. So when the object moves, so that means this part is equal to 0, Vxi. V initial t, so that means V initial at x, V initial V cosine theta t. The other part it's equal to 0. So that's it. So in x we have only 2 important equations. Number 1, the important equation number 1, and this equation number 2, that is important 2 equations, and this you can discover it from the second equation. هذه معادلتين أساسيات ومعادلة مستنتجة، لأنه إذا كان التسارع يساوي 0 فهذا يعني أن السرعة النهائية تساوي السرعة الابتدائية. So that is part 1. Part 2 in y-axis. In y-axis, Vi in y it's equal to Vi sine theta that we mentioned about it in first equation. Then applied these 3 equations. So V final y is equal to, just substitute or replaced V initial with V initial in y. So V initial sine theta minus gt with second equation, with third equation, with 3 dimensions. Just only put the components x and y. At x, the acceleration is equal to 0. At y, means the same, so that means 9.8 at j, or at any value that is given in the question. So that is the important equations in this chapter. Now we want to find the maximum height. So that means at point 4. At point 4, what is v final y? So it equal to 0. So what is the equations there? The work is in y. So what is the equation of y? It's maximum height, so that means delta y. So applied the second equation, the second equation, v final square, that's in y, because I need it in y. The maximum point is in y, maximum height, equal to v initial square minus 2g delta y. Just replace the v initial here, v final, as we mentioned, in maximum height, in this point as a maximum, so here vy is equal to 0. So vy 0 is equal, replaced v initial y with v initial sine theta I squared minus 2g delta y. Move this to other side, so 2g delta y, it's equal to v initial sine theta I squared. So just replace delta y with h as a maximum height, so h is equal to v initial sine squared theta, v initial squared sine theta squared divided by 2g. So that is the first equation of the maximum height when it's firing from 0. When it's firing from 0, y is equal to 0, and the shape as symmetric or identical. So h, the maximum height, it's equal to v initial squared sine squared theta divided by 2g from the second equation. Number 3. So we have first important equation as I discussed with you. V initial x is equal, I write it in other color. Sorry, I write it in other color to you to know it. The first important equations in symmetric. So v initial x is equal to v initial x cosine theta. Then v initial y is equal to v initial sine theta I. So that is the first equation. The second for the maximum. Now I want for the range. Before the range, I want to know the time. What is the time to take reach, or to take up, or to take down, or I can find the so now how to find the time. So we have two time, as I mentioned to you. One time to the projectile to take the maximum height, so that is T1. Then the second to reach from the maximum to reach the ground, T2. So the total time for the symmetric or identical shape, so it's equal T, or T total, it's equal to 2T. What is the mean of 2T? It's T1, T of firing till the reach the maximum, then from the maximum to the ground. So how you can find the T at first? So from the first equation, V, it's working in Y, so V final Y equal to V initial Y minus GT. Vy in this point to reach the maximum, so it's equal to 0. V initial Y, it is V initial sine theta minus GT. So move this to the other side. So GT, it's equal to V initial sine theta, then T, it's equal to V initial sine theta divided by G. So that is the time to fly to the maximum point. So the total time, the time to fly to the maximum point, is the time to reach the ground, from the maximum to reach the ground. So that is the same of equal to T2. It's same. So the T total, it's equal to 2 divided by this one, be divided by T. So it's equal to 2 Vi sine theta divided by G. So that is the total time. إذا زمن التحليق هو نفسه زمن الوصول إلى المستوى المرجعي اللي هو سطح الأرض. فإذا كان الزمن التحليق لوصول إلى أقصى ارتفاع VI sin theta over G, so to reach the ground it is the same but twice, so that means 2 VI sin theta divided by G. So now we find the important three equations. Number 1, the combination of X and Y. Number 2, the maximum height. Number 3, the time as T as time to take a reach, to reach a maximum height, or to reach the ground as a T total. So in some equations they not given you any information about V, about sine, just only give you the maximum height. How you can find the T from this equations. So you know from the second equation, of the maximum v, that is one of special case sometimes not given or not mentioned about the sine or v initial, and he wanted time to complete the other calculation. How you can find it? So you can find it from the second equation. So second equations, first and second, you can find it. T squared is equal to 2h divided by g. So t is equal to the square root of 2h divided by g, and this is a special case if not mentioned in the question about the v initial or theta. So you can find the t direct from the twice height divided by the gravitation. Now just only we have the fourth important equation, it's r, the range. How you can find the range? We know the range, it is in x-axis, so that means delta x. So delta x equation is equal to v initial x t. So what is v? What is delta x? Delta x is equal to v initial cosine theta I t. عوض عن قيمة c, substitute t. What is t? T is a total because it moves from start till the end. So t and t2. So here in this point, that point I want to calculate it. So delta x or r as a range and we find from the last equation that is v, the t total is equal to tvi cosine sine theta I divided by g. So just only replace the t with this equation. So and replace delta x with r as a range. So v initial cosine theta I dot to v initial sine theta I divided by g. In mathematics, 2 sine theta cosine theta, so this part is equal to sine 2 theta. So this part is equal to this part, this equation. So that means this 2 sine with 2 with this one. So there is only v with v squared. So r as a range, it's equal to v initial square sine 2 theta twice of the angle from mathematical equation divided by g. So that is the equation of the range. So that is the important three equation in identical or symmetric when the launching from starting from the ground. So y is equal to 0. So that means there is a maximum height, range, and also the time of the flight. It's equal to the time to reach the ground. The time of to flight to reach the maximum is equal to the time from the maximum to the ground, and that is the important equation in this part. See you and good luck. That is the second lecture. The third lecture, it's a very important lecture, and I give you some exercise. Okay, and good luck.